Hello everyone. Am I visible and audible to everyone?
Yes, sir.
Okay. So let's begin today's class. And in the last class, we have discussed about the formation of stars and stars' life, I think so. Let me open one slide, which I have already shared to the GS student. So that will help us make notes out of it. So as we have covered various theories, and not only theories, we have also covered origin of a star and all that. The next topic which is left is the solar system. I hope you understand all these things. And this notes is also shared to you. Fine. There's some written part here. It's part of that. So let's begin today's class. Let me share the board first. So in this particular notes, you will find all the topic related with astronomy, which is equally important for your optional as well as GS, as well as fundamentals of geography, right? So this is what Big Bang theory, we have discussed it, and the different phases of formation of different, what you can say, celestial body like star formation, then planet formation, and what will be the next, etc. will be discussed. What were the evidence in support of Big Bang theory? So Hubble's redshift, and after Hubble's redshift, we have other things like uh, the the cosmic background explorer satellite. That is also one of the evidence. So what is redshift? We have discussed about redshift or not? Evidence in support of Big Bang theory. So Edwin Hubble talks about Edwin Hubble. He talked about that universe is expanding. Universe is expanding. And he proved this expansion of universe theory by a phenomena which he observed in various galaxies, and this was redshift. So if a star is moving away from you, if a star is moving away from you, its light is going to diminish. That means if the star was earlier producing blue light, but now it is producing orange, that means same star is producing less energy light. So this shift is towards red. Why? Because V, I, P, G, Y, O, R. This is what? Different wavelength. So violet is what? High energy, and red is of low energy. So when there is a star which is showing what? Orange color, earlier it was blue in color, that means the color of the light is getting what? Lower energy. और ये तभी हो सकता है जब star is moving away from you and you are watching it from the earth. आप अर्थ से इसे देख रहे हो. So the star is moving away from you, and it was observed in various cases. And it can only be possible when things are moving apart. That means universe is expanding. Universe is expanding. And this expanding universe is actually because of the Big Bang. Somewhere it was close, and because of the bang, it is now moving apart. So this redshift phenomena, which was observed by Edwin Hubble in way back in 1929, and it supported this Big Bang hypothesis. Fine. So these were the evidences. I hope you understand. Then this is Cosmic Background Explorer satellite, which was launched by NASA to understand, to see the cosmic, what you can say, radiations. So radiations which were released after Big Bang. After Big Bang. So after many years from Big Bang, photons were formed and they generated the first radiation. These were the first radiation. First radiation released after Big Bang. So for knowing it, NASA have launched this satellite way back in 1989, and this Cosmic Background Explorer satellite have seen those radiations. This is a picture in which you can see the galaxy, a typical structure of a galaxy, where the center is what? The black hole. The center is what? The black hole. Here it is the black hole. Okay, and then you will see the first arm, the second arm, the third arm, and rest we have discussed already. And revolving around this black hole in anticlockwise direction, you will find the new star in outermost arm, mature star and all. This is another, what you can say, picture which is of galaxy. Again, you can see the black hole at the center and different zone over there, isn't it? And galaxy can be of different shape. It's a revision class also, जो हम लोग पढ़े उसको एक बार रिवाइज करने की कोशिश कर रहा हूँ. Okay, so spiral, maybe elliptical, maybe irregular in shape. This is what the galaxy. Further, here we can see the superclusters of galaxy. These are the superclusters. Superclusters of galaxy. Those superclusters which were formed, gases were aggregated, accretion was there, and each supercluster transformed into galaxy. For example, this is our galaxy, which is called as Milky Way. And here our neighboring galaxy, that is what? Andromeda. Andromeda is the neighboring galaxy, which is 4.2 million light year from us. ये नजदीक वाली गैलेक्सी की हालत है. And 1 light year is a distance in which light travel whatever the distance in 1 year, and it comes to be 9.46 into 10 to the power 12 kilometer. This is the light year. So the neighboring galaxy, which is what? Andromeda, NGC 6822, NGC 185, these are the neighboring galaxy. Triangulum is there. This is Triangulum. Andromeda, Triangulum, these are the neighboring galaxy, and they are far, far away. ये पास की गैलेक्सी है, इनकी बात है बच्चे. Andromeda. Here you will find this Triangulum. Okay, so Andromeda closest. Next one is Triangulum. And there are many galaxies which has been named. Okay, now this is the picture in which you can see the solar system. हैंग हो जा रहा है भाई, क्या चक्कर है? Fine. In this particular picture, you can see the sun. This is our sun. And here the solar system. So in this, our solar system, we have 8 planets. We have 8 planets. Fine. Before 2006, there were how many planets? 9 planets. Okay. Pluto was the 9th planet. Pluto. But since 2006, Pluto is no more planet and it is considered as dwarf planet. Fine. Dwarf planet. So right now in our solar system, we have 8 planets. We have so many moons. Apart from it, we have also the asteroid. asteroid. And outer solar system, we have comets. Then we have certain belts, like there is habitable belt, habitable zone. Then we have, which is also called as Goldilocks zone. We have Goldilocks belt. Then we have asteroid belt. Asteroid belt. Then we have the Kuiper belt. Kuiper belt, which is also called as trans-Neptunian belt. And that is also called as trans-Neptunian belt. Trans-Neptunian belt. And beyond it, there is Oort cloud. Oort cloud. This Oort cloud, up to Oort cloud, we have an extension of solar system. This is the limit of our solar system. Limit of solar system. So our solar system consists of 8 major planets. So 8 planets are there. And Mercury, Venus, Earth, Mars. These are called as inner planets. They are called as inner planets. And they are also called as terrestrial planet. Terrestrial planet. अच्छा, ये बने कैसे, इसको हम लोग बात कर चुके हैं. Tidal hypothesis, planetesimal hypothesis, है ना? So these are terrestrial planet. And from Jupiter to Neptune, it is what we call outer planet. Outer planet. And these outer planet are also called as Jovian planet. Jovian planet. It is also called as Jovian planet. Okay. Jovian means Jupiter-like planet. Jupiter-like planet. They are made up of gases. They are made up of gases. है ना? अगर आप इस पे ऐसे खड़े होंगे, so you are not going to get the hard substratum. You just fall inside the Jupiter. While these are terrestrial planet. If you are standing over here, you will find a hard substratum over here. That's why it is called as terrestrial planet, or we call it Earth-like planet. Earth-like. It is called as Earth-like planet. Fine, all the 4, Mercury, Venus, Earth, Mars, they all are called as Earth-like planet. Out of this Jovian planet, these 2, Jupiter and Saturn, they are called as gas giants. Gas giants. While the Uranus and Neptune, they are called as ice giant. इनको ice giants कहते हैं बच्चे. ये भी गैस के ही बने हैं, लेकिन इतने दूर हैं कि they are frozen. They are frozen. So they are frozen gas giant, and hence they are called as ice giant. Jupiter, Saturn, Uranus, and Neptune. ठीक है बच्चे? So these are our 8 planets. In this particular picture, you can see the sun. And this is what sun surface. Sun surface. And this sun surface is called as photosphere. Photosphere. Fine. And whatever you can see in form of these flares, ज्वालाएं दिख रही होंगी आपको. These are called as solar flares. These are solar flares. सौर ज्वालाएं हैं बच्चे. और ये जो चमकदार सरफेस आपको दिख रहे हैं, these are actually the spots. Sun spots. इसको हम लोग चलिए डिटेल में पढ़ते हैं. So let's begin with the interior of the sun. In this particular picture, you can see the sun's interior. And you will find that there is a core where the hydrogen fusion reaction is taking place. And there is formation of helium. And in the process, energy is released. Fine. And this energy is start radiating through this core and reaching to radiative zone. रेडिएटिव जोन इज ऑल्सो मेड अप ऑफ गैसेस. कौन सी गैसेस हैं बच्चे सूरज में? हाइड्रोजन, that accounts for 71.5%. Helium, which accounts for almost 26%. And rest are other elements. Other elements. So in radiative zone also, we happen to have these gases in abundance. अब रेडिएटिव जोन बहुत हाई प्रेशर पे है बच्चे, इसलिए इसमें कन्वेक्शन नहीं हो पाता और रेडिएशन से ऊर्जा बाहर निकलती है. ऊर्जा निकल के कन्वेक्टिव जोन में पहुंचती है. दिस इज व्हाट कन्वेक्टिव जोन. दिस इज योर कन्वेक्टिव जोन. और कन्वेक्टिव जोन की गैसेस फ्री होती हैं. यहां भी हाइड्रोजन और हीलियम ही है, लेकिन प्रेशर कम होने के कारण दे आर मूवेबल, दे कैन मूव. सो ड्यू टू मूवमेंट देयर इज फॉर्मेशन ऑफ कन्वेक्शनल करंट. फॉर्मेशन ऑफ कन्वेक्शनल करंट. And these convectional current are very strong, है ना? और ये कन्वेक्शनल करंट इतनी स्ट्रांग होती है कि यहां से सोलर फ्लेयर के रूप में कोरोनल मास इजेक्शन हो जाता है. सो देयर इज अ कोरोनल मास इजेक्शन, जिसको हम सोलर फ्लेयर के रूप में देख रहे थे. सो जो बाहर निकली हुई ज्वालाएं थी वो असल में कोरोनल मास इजेक्शन था, जो हुआ किस लिए? क्योंकि स्ट्रॉन्ग कन्वेक्शनल करंट्स आर बीइंग. ठीक है. अब कन्वेक्टिव जोन के ऊपर कौन सा जोन है बच्चे? देयर इज अ फोटोस्फीयर. दिस इज द सरफेस ऑफ द सन which has a temperature of the range 6000 degree centigrade, while the radiative zone has a temperature of 1 to 10 million degree centigrade. Okay, while the convective zone has a temperature of 14,000 to 20,000 degree centigrade. This is the temperature range. And the photosphere, which is the uppermost surface, is at 6000 degree centigrade, which is the bright surface of the sun. Photosphere. And just above the photosphere, there is a zone of chromosphere, which is a little bit less, means at less temperature of range 4500 degree centigrade. This is chromosphere, which is a little bit darker as compared to photosphere. So chromosphere is there. And beyond this sun surface, when you move for lakhs of kilometer from sun surface, there is a zone of corona. यहाँ पे आपको कोरोना मिलता. Corona is a halo of the sun, which is lakhs of kilometer from the sun surface. कई लाख किलोमीटर जब आप दूर आते हो, ये जो हेलो आपको दिखाई पड़ रहा है, दिस इज कॉल्ड एज कोरोना. एंड कोरोना इज एट वेरी हाई टेम्परेचर. सो जो सन का कोरोना होता है बच्चे, दैट हैज अ टेम्परेचर ऑफ 10 लाख डिग्री सेंटीग्रेड. 10 लाख डिग्री सेंटीग्रेड. अब आपको आश्चर्य होगा कि सन का सरफेस का टेम्परेचर 6000 डिग्री सेंटीग्रेड है, और उससे लाखों किलोमीटर दूर कोरोना का टेम्परेचर कितना है बच्चे? 10 लाख डिग्री सेंटीग्रेड. ये एनोमली क्यों? सो दिस इज ऑल्सो कॉल्ड एज प्रॉब्लम ऑफ कोरोनल हीटिंग. कोरोनल हीटिंग. इट वॉज फर्स्ट ऑब्जर्व्ड इन द ईयर 1939. 1939 में इसके बारे में पता चला. क्या पता चला? कि कोरोना, जो कि सूरज से लाखों किलोमीटर दूर है, उसका तापमान 10 लाख डिग्री सेंटीग्रेड, जबकि सोर्स जहां से ये हीट आ रही है, उसके अपर सरफेस का तापमान जस्ट 6000 डिग्री सेंटीग्रेड. ऐसा कैसे हो सकता है कि सोर्स कम तापमान पे हो और उससे लाखों किलोमीटर दूर सिंक अधिक तापमान पे? और ये सिचुएशन, कुछ इस तरह की प्रॉब्लम, ये एनोमली ऐसी प्रॉब्लम क्रिएट करती है जो 20वीं शताब्दी की प्रॉब्लम ऑफ द सेंचुरी कही जाती है. दिस प्रॉब्लम ऑफ कोरोनल हीटिंग, जब आप नेट पे सर्च करोगे, यू विल फाइंड दैट इट इज द प्रॉब्लम ऑफ 20th सेंचुरी. इसको 20th सेंचुरी की प्रॉब्लम कहा जाता है कि भाई कोरोना इतने अधिक टेम्परेचर पे क्यों है. So this is what the interior of the सन एज वेल एज कोरोना। कोरोना का इस अधिक तापमान पे होने का जो सबसे अच्छा एक्सप्लेनेशन है बच्चे, वो यूजीन पार्कर ने दिया है। यूजीन पार्कर, आप ध्यान से देखिए, यहाँ पे कोरोनल मास इजेक्शन हो रहा है। दिस इज व्हाट शोइंग कोरोनल मास इजेक्शन। अब ये कोरोनल मास इजेक्शन में क्या क्या चीजें होती हैं बच्चे? क्यों कोरोनल मास इजेक्शन हो रहा है? क्योंकि अंदर स्ट्रॉन्ग कन्वेक्शनल करंट बनी थी। और स्ट्रॉन्ग कन्वेक्शनल करंट क्यों बनी थी? बिकॉज ऑफ massive heating. That's why this coronal mass ejection takes place, and it contains hot gases. Without any doubt, this hot gases will be there. Along with it, charges will be there, and along with it, there will be electromagnetic radiation. Electromagnetic radiation. इनको कलेक्टिवली आप क्या कहते हैं? कोरोनल मास इजेक्शन। और जब ये कोरोनल मास इजेक्शन इस तरह से आगे बढ़ता है बच्चे, सो दिस वी कॉल सोलर फ्लेयर। सोलर फ्लेयर। तो आपने पहले पेज में देखा था, पहले चित्र में ही, ये जो बाहर निकल रहा है, दिस इज व्हाट सोलर फ्लेयर। एंड सोलर फ्लेयर कंसिस्ट ऑफ indeed the hot gases, charges, as well as electromagnetic radiation. Let me show you the solar flare in realistic way. Try to see. This is what the coronal mass ejection. This is what the coronal mass ejection. And these are the solar flare. And these solar flare consist of hot gases. हॉट गैसेस में क्या होंगे बच्चे? ऑब्वियसली देयर विल बी हाइड्रोजन एंड हीलियम। अपार्ट फ्रॉम इट देयर विल बी चार्जेस, एंड यस, एनर्जी इज आल्सो कमिंग आउट इन फॉर्म ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन, जो प्रकाश के रूप में आगे चलेंगे, है ना? सो दिस इज व्हाट कोरोनल मास इजेक्शन एंड सोलर फ्लेयर। सिमिलरली यू विल फाइंड दिस कोरोनल मास इजेक्शन in this figure also. या ये जो आप देख पा रहे हैं, it is what depicting the convectional current formation over here in convective zone. So this is what coronal mass ejection. This is one coronal mass ejection. And if you want to know the size of coronal mass ejection, what is the size of coronal mass ejection? So there is Earth that has been kept over here just to compare how bigger these coronal mass ejections are. ये पृथ्वी को यहाँ रखा गया है सिर्फ इसीलिए कि आप जान सके कि कोरोनल मास इजेक्शन कितनी बड़ी साइज में हो। सो 15 to 20 times even more than the earth shape. This is what the coronal mass ejection taking place at one time, okay, which consists of hot gases, charges and electromagnetic radiation. अब क्या होता है बच्चे? ये सूरज है। सूरज से जब कोरोनल मास इजेक्शंस होते हैं तो ये नैनो फाइबर्स के रूप में निकलते हैं, जिनको स्पिक्यूल्स कहा जाता है। स्पिक्यूल्स, माइक्रो स्पिक्यूल्स, ओके। और ये माइक्रो स्पिक्यूल्स क्या है बच्चे? दे आर द बंडल्स ऑफ एनर्जी। बंडल्स ऑफ एनर्जी। और खास बात इनकी है, दे आर शॉर्ट लिव्ड। ये बहुत कम समय के लिए इंटैक्ट रहते हैं, एंड दे आर वेरी फास्ट मूविंग। What is the speed? They are moving at a speed of light. Speed of light. And they are short lived, बहुत कम समय के लिए, विद इन 1 सेकेंड ये खत्म हो जाते हैं, लेकिन उतनी ही देर में बहुत तेजी से मूव कर जाते हैं। तो मान लो ये हो गए आपके नैनो स्पिक्यूल्स, एंड दीज स्पिक्यूल्स आर containing nothing but energy. What energy? Which is coming from the interior of the sun. These are spicules blasted off from the sun surface, and they are short lived. Short lived का मतलब इनका लाइफ कम है, लेकिन दे आर फास्ट मूविंग। तो यहां से जैसे निकलते हैं, दे ट्रेवल फास्ट, और अगले ही सेकंड ये क्या हो जाते हैं? डिसइंटीग्रेट हो जाते हैं बच्चे। और जब डिसइंटीग्रेट होते हैं तो इसके अंदर की एनर्जी कहाँ निकल आती होगी? बाहर निकल आती होगी. So they are carrying heat. They are the small packets of heat. And when they disintegrated, in that very point of time, they reach to the corona. और कोरोना में जाकर के ये हीट रिलीज कर देते हैं. दिस इज द रीजन वाई कोरोना गेट हीटेड मोर. कोरोना में ही हीट रिलीज होगी बच्चे. सो कोरोना हैज अ टेम्परेचर ऑफ 10 lakh degree centigrade. This is the explanation which was given by Eugene Parker. There are microfibers, nanofibers are spicules. They are containing heat. They contain this heat energy, and they are short-lived and fast-moving. और जब यहाँ से ये blast off होते हैं, यहाँ से eject out होते हैं, in this means several spicules has been fired from here, and they travel within few seconds. Means within second they reach to the corona, where they disintegrate and release this heat. This heat released. And due to that, corona is at very high temperature. This was an anomaly which was considered as the problem of 21st century. Problem of 21st century. Oh, sorry, 20th century. Problem of 20th century coronal heating, जिसको यूजीन पार्कर ने 21st century के पहले डेकेड में एक्सप्लेन करने की कोशिश की. ठीक है. अभी भी ये एक्सप्लेनेशन साइंटिफिक एरिना में पूरी तरह से एक्सेप्टेड नहीं है, लेकिन कुछ तो है जो ये बताने के काबिल है कि हाँ, कोरोना क्यों इतने ज्यादा टेम्परेचर पे है. इज इट अंडरस्टैंडेबल टू एवरीवन?
यस सर.
श्योर. कोई कंफ्यूजन हो तो पूछें आप.
Yes, sir.
Okay. So problem of coronal heating, we discussed about the explanation. We also discussed this coronal mass ejection. अब coronal mass ejection हुआ तो उसके आगे क्या होता है बच्चे? आप ध्यान से देखें इस चित्र में. तो coronal mass ejection होने के बाद gases start moving away from the sun, and they moved for several kilometers, thousands of kilometers, thousands of kilometers. These gases, hot gases moved. These are hot gases. है ना बच्चे? ये hot gases भी हैं, and they are also associated with charged particle. There are certain charged particle. इनके पास कुछ charged particle भी हैं. They are not merely the hot gases. They are also having electromagnetic radiation, and they are also having charged particle. And obviously hot gases. तो बच्चे सन के पास ग्रेविटी है कि नहीं? सन हैज ग्रेविटी. तो सन क्या करेगा? अपनी ग्रेविटी का यूज करेगा. अब इलेक्ट्रोमैग्नेटिक रेडिएशन एंड चार्जेस, दे आर मासलेस. बट व्हाट अबाउट हॉट गैसेस? दे कंटेन मास. तो फिर क्या होगा बच्चे? इन हॉट गैसेस को वापस सूरज अपनी ग्रेविटी से खींचना शुरू करेगा. एंड दीज हॉट गैसेस आर रिटर्निंग बैक. These hot gases are returning back. In the journey of thousands of kilometers going and thousands of kilometers coming, these hot gases, they become cooled. They get cooled. And they are pouring onto the Earth's surface. Pouring onto the bright photosphere. Bright photosphere, where the temperature is 6000 degree centigrade. यहाँ का टेम्परेचर कितना है बच्चे? 6000 डिग्री सेंटीग्रेड. लेकिन जब ठंडी गैसें इस पे आएंगी तो देयर विल बी रीडिस्ट्रीब्यूशन ऑफ हीट, एंड टेम्परेचर बिकम ऑफ द रेंज 2500 to 3000 degree centigrade. Obviously, on a surface which is what, bright, of 6000 degree centigrade, these area seems to be cooler patches. Cooler patches. And from the earth, you can observe it as a spot. and these are called as sunspot. तो sunspot बने कैसे? Coronal mass ejection के कारण बनते हैं बच्चे. Under the influence of massive convectional current, huge amount of coronal mass ejected out. Try to see here, ejection of coronal mass. And in the coronal mass, what you are going to see, there will be electromagnetic radiation, charges as well as hot gases. And these hot gases, they are containing mass. Although they moved for several thousand kilometers, but they were again attracted by the sun's gravity and they have to return. And they return back, and in the process, they get cooled. And they are pouring onto the bright photosphere, and there is a redistribution of heat, creating a zone which is having average temperature of 2500 to 3000 degrees centigrade, which looks like a cooler patch on the sun's surface. And from the earth, when you see these cooler patches, it will look like a spot, which we call sunspot. यहां से गैसेस तो वापस आ गई बच्चे, लेकिन इलेक्ट्रोमैग्नेटिक रेडिएशन, चूंकि वो उनमें मास नहीं है, और चार्जेस, दे कंटिन्यूड देयर जर्नी. और जब ये अर्थ के पास पहुंचते हैं, तो यहाँ पे इसको सोलर स्टॉर्म के नाम से जाना जाता है. सोलर स्टॉर्म. So what is solar storm? It is electromagnetic radiation as well as charges which is reaching to the earth, and it is because of massive coronal mass ejection. This is what coronal mass ejection. So coronal mass ejection में जो hot gases थी वो तो वापस चली आई, लेकिन इलेक्ट्रोमैग्नेटिक रेडिएशन और चार्जेस पहुंचेंगे अर्थ तक, जिनको सोलर स्टॉर्म या सोलर विंड के नाम से जानते हैं, और इसके इंपैक्ट होंगे अर्थ पे, जिसको चर्चा आगे करेंगे. फिलहाल सन स्पॉट देखते हैं बच्चे. जब सन स्पॉट्स बनते हैं तो वो कैसे दिखते हैं? लेट मी शो यू. When you are watching this sunspot, it looks like cooler patches like here. These are the sunspot. Fine. And these sunspots are actually following a cyclic pattern, which we call sunspot cycle. Sunspot cycle. And the sunspot cycle was observed by Samuel Henry Schwabe. Samuel Henry Schwabe, in the year 1843, he observed this sunspot cycle. और उसने कहा कि ये sunspot cycle is undergoing two prominent phase. One is solar minima phase. Another one is solar maxima phase. सोलर मिनिमा और सोलर मैक्सिमा से इनका अभिप्राय यह था कि इन केस ऑफ सोलर मिनिमा देयर इज लेस कोरोनल मास इजेक्शन. ट्राई टू सी दीज टू फिगर. वन इज रिप्रेजेंटिंग सोलर मिनिमा. These two figures, solar minima, and another one is representing solar maximum. Here it is solar minimum. Try to see the sunspot. These are sunspots, smaller sunspots. Okay. So there will be less sunspot, less number of sunspot as well as smaller size sunspot. And it is because there is less solar activity or less coronal mass ejection. Less coronal mass ejection. So due to less coronal mass ejection, there will be less sunspot. Less sunspot and small size sunspot. And that's why we call it solar minima phase. This is what solar minima phase. And here what is there? Solar maxima phase. Solar maximum. Try to see the number of sunspot. These all are going to be the number of sunspot. And bigger sunspot. These all are sunspot. They are bigger in size, more in number. These are the sunspots. So what is solar maxima? large number of sunspots. What about size? Large size of sunspot. Large number of sunspot and large size of sunspot. Both are going to be there. Why there is a large size of sunspot? Because there is more coronal mass ejection. More coronal mass ejection. So there is more ejection of hot gases, more return of cool gases. That's why larger cycle. This is what solar maxima phase. When more solar activity is taking place. और ये सब कुछ कौन देख रहा था? सैमुअल हेनरिक स्वाबे. और उसने क्या किया? एक सिंपल ग्राफ बनाया बच्चे. जिस ग्राफ में उसने क्या दिखाया? हर साल जितने नंबर ऑफ सन स्पॉट्स हो रहे थे उनको नोट करता गया. तो इसमें अगर आप देखें बच्चे, so this graph has pattern. So there is a solar minima phase. This is solar minima. When less number of sun spots are there, less coronal mass ejection is there. But there is a situation when there is a solar maximum. This is what solar maxima, when the number of sunspot is more and when the size of sunspot is also more. And again it comes to be minimum. So there is a minimum, then there is a maximum, then again the plateau reached and minimum. So there is one solar minima here, another solar minimum. So time taken from one solar minima to another solar minima is what? A complete sunspot cycle. Sunspot cycle. And it takes 11 years to be completed. 11 years. And this was the finding of Samuel Henrik Schwabe. अभी जो चल रहा है वो 25th सनस्पॉट साइकिल चल रही है, जो 2020 से शुरू हुई थी बच्चे. 2020 और 2031 तक ये खत्म हो जाएगी. और अभी हम लोग कहाँ हैं? 2024, 25, 26, 27. It's going to be the solar maxima phase. सोलर मैक्सिमा फेज. अभी जो समय चल रहा है वो सोलर मैक्सिमा का चल रहा है. इसका मतलब मोर एंड मोर कोरोनल मास इजेक्शन इज टेकिंग प्लेस. कोरोनल मास इजेक्शन ज्यादा हो रहे हैं और ज्यादा कोरोनल मास इजेक्शन होंगे बच्चे तो अर्थ पे सोलर विंड्स ज्यादा आएंगी. मोर सोलर विंड्स आर गोइंग टू स्ट्राइक द अर्थ. सो देयर विल बी मोर रिपरकशन इन फॉर्म ऑफ एक्सट्रीम वेदर कंडीशन. एक्सट्रीम वेदर कंडीशंस भी ज्यादा होंगे. आपने इधर भी सुना भी होगा, कहीं क्लाउड बस्ट हो रहा है, कहीं बाढ़ आ रही है ना, कहीं सूखा भी पड़ा, कहीं हीट वेव, कहीं कोल्ड वेव. So these are the extreme weather condition. You will find increased extreme weather condition in solar maxima phase. Solar maxima phase. ऐसी सिचुएशन पहली बार नहीं आई है बच्चे. जो 24th साइकिल थी उसका भी सोलर मैक्सिमा फेज 2014 से लेके 2017 के बीच रहा होगा. In that situation also, extreme weather condition was increased by many fold because Earth is likely to receive more heat. Earth receives more heat. अब अर्थ के पास ज्यादा हीट होगा बच्चे तो उसको अपने किसी न किसी काम में लगाएगी. अब उसने हीटिंग पे ही लगा दिया, साइक्लोन स्ट्रॉन्ग कर दिए. सो दिस एक्स्ट्रा हीट विल बी सीन एज अ रिपरकशन ऑफ क्लाइमेट. सो जब भी सोलर मैक्सिमा फेज होगा, जब कभी भी, तो एक्सट्रीम वेदर कंडीशंस बढ़ जाते हैं. और भी बहुत सारी चीजें होती हैं जैसे अरोरा फॉर्मेशन. इंटेंस अरोरा आर बीइंग फॉर्म्ड. इंटेंस अरोरा आर बीइंग फॉर्म्ड. इंटेंस अरोरा. अरोरा फॉर्मेशन है ना. The solar wind can change the orbit of the satellite. Orbit of the satellite can change. It can affect telecommunication. It can affect telecommunication. Satellite communication. So whatever is based on satellite communication is going to be affected. Okay. It can also responsible for power grid failure. So strong solar storms or wind on Earth can create these kind of havoc. It can affect atmospheric circulation, atmospheric telecommunication. Atmospheric telecommunication. So these are the impacts of solar wind on the Earth. Impacts of solar wind. तो सोलर विंड के इम्पैक्ट अर्थ पे देखे जाएंगे और खास करके सोलर मैक्सिमा फेज, जैसे आप यहाँ देख पा रहे हो साइकिल 24th यानी पिछली साइकिल जो 2009 के आसपास चली होगी 2020 तक खत्म हुई होगी, है ना। उससे पहले 23rd साइकिल, उससे पहले 22nd साइकिल, एंड दिस इज हाउ इट वाज started since 1843 जब से पहली सन स्पॉट साइकिल डिकोड हुई थी सैमुअल हेनरिक स्वाबे से। So you understand what is sunspot cycle, coronal mass ejection, solar flare and solar wind? Let me know your take. Are you able to decipher it?
Yes, sir.
So you understand this sunspot cycle, solar maxima, solar minima, coronal mass ejection. So under the influence of what? Massive convectional current. What happened? Huge amount of solar mass ejected out that contains hot gases, that contains electromagnetic radiation and charges. और क्या होता है बच्चे, ग्रेविटी के कारण हॉट गैसेस तो वापस आ जाती हैं, लेकिन इलेक्ट्रोमैग्नेटिक रेडिएशन और चार्जेस उनको आप रोक नहीं पाते, एंड दे ट्रेवल एंड दे रीच ऑन टू द अर्थ, और अर्थ उसे बड़े ही ढंग से अवॉइड कर देती है बच्चे। अर्थ का जो मैग्नेटिज्म है, अर्थ हैव डेवलप्ड इट्स मैग्नेटिज्म अराउंड इट, एंड दिस मैग्नेटिज्म इज रिस्पॉन्सिबल फॉर अवॉइडिंग, दिस इज नॉर्थ पोल, देयर इट इज साउथ पोल, स्ट्रॉन्ग सोलर विंड्स आर रीचिंग ओवर देयर, and this magnetism is actually diverting this solar wind towards the pole. So these solar wind get diverted towards the pole and travel into the space without altering the Earth's atmosphere much. And once they are reaching onto the polar atmosphere, thermosphere, they produce aurora, polar light, aurora borealis. आई होप ये सारी चीजें आप जानते होंगे, अरोरा बोरियलिस एंड अरोरा ऑस्ट्रेलिस, अरोरा बोरियलिस एंड अरोरा ऑस्ट्रेलिस. Auroras are polar light. Auroras are polar light, polar lights produced due to interaction of electromagnetic radiation, charges with ionized gases of ionosphere. So there is a charge-charge interaction, and that produces light, and that we call aurora. And when the strong solar winds are there, strong solar wind, what happens? Intense aurora can be formed. Intense aurora. Stronger will be solar wind, more intense will be aurora. और जब intense aurora होते हैं बच्चे, तो they are observable from the mid latitude. They are observed from the mid latitude. इसीलिए आपने कुछ समय पहले लद्दाख से अरोरा के देखने की बात सुनी होगी. From Ladakh, we were able to see aurora, and Ladakh is actually in the mid latitude because most of the North India is situated. Most of the North India, twice the area of South India. It is North India is situated in the temperate zone. तो लद्दाख कहाँ है बच्चे, आप देख पा रहे हो 35-37 डिग्री के आसपास है. So 35 degree north is what? Temperate latitude. So it's some mid latitude region जहां से अरोरा इंटेंस अरोरा दिख जाते हैं. हमें नहीं दिखेंगे क्योंकि हम लोग काफी साउथ में हैं एज कंपेयर टू लद्दाख. ठीक है. So this is solar wind. Is it understandable to everyone? Sir, what is chromosphere and photosphere and difference between them? आइए बताता हूँ difference. Let me have this. देखो, this is the surface of the sun, which is called as photosphere, the bright surface of sun. Photosphere, which has a temperature 6000 degrees centigrade. And just above this photosphere, there is a low temperature zone, which also seen as a dark zone. It looks dark, where the temperature is of the range 4500 degree centigrade. And this zone is called as chromosphere. Chromosphere. So chromosphere is just above the photosphere. Photosphere is made up of hydrogen and helium gases, while the chromosphere is what? Nothing but it's a zone that is created just above the photosphere. Fine. And it has lower temperature as compared to photosphere. Is it clear to everyone?
Yes, sir.
Excuse me, sir.
ठीक है बच्चे.
Hello.
हाँ जी बताएं.
Sir, if the chromosphere is the outermost layer, then why not the sunspot is forming at the chromosphere and only forming at the photosphere?
क्या क्या कहा आपने? Why?
सर अगर क्रोमोस्फीयर सन का outermost layer है,
हाँ.
as it is present just above the photosphere, then the sunspot is why it is not forming at the chromosphere, why it is forming at the sir, why the sunspots
हाँ.
they are not forming at the chromosphere?
Okay, fine. Why not sunspot is not forming? This is photosphere ना. ये photosphere यहाँ देख पा रहे हो आप photosphere? Let me show you. This is photosphere. Is it visible? Photosphere, which is made up of hydrogen as well as helium. Okay. और just above इसके क्या है बच्चे? This is chromosphere. तो जहां पे सरफेस होगा सब्सटेंस का बना हुआ, वहीं पे तो आगे गैस मिलेंगी ना. क्रोमोस्फीयर इज अ जोन. इट्स नॉट मेड अप ऑफ हाइड्रोजन एंड हीलियम. यहां कोई सब्सटेंस नहीं है. इट्स अ जोन. ओके, विच इज अ डार्क जोन एज कंपेयर टू फोटोस्फीयर. दिस जोन इज कॉल्ड एज क्रोमोस्फीयर. फाइन. तो यहाँ सन स्पॉट इस पे थोड़ी बन पाएंगे. यहाँ तो कुछ है ही नहीं. गैसेस तो यहाँ आएंगी ना बच्चे. समझ गए?
Yes sir, got it.
कहीं स्पॉट बनने के लिए वहां पे क्या चाहिए? सब्सटेंस तो चाहिए. हवा में थोड़ी बनेगा. ठीक है. सो जस्ट above the photosphere zone is called as chromosphere, which is what little bit darker ना, क्योंकि वहां टेम्परेचर फोटोस्फीयर जैसा ब्राइट नहीं है. इज इट ओके टू एवरीवन?
Yes, sir.
Okay. Acha, this is what one structure in which our solar system is visible. Try to see, the center is occupied by our sun, and then there is the nearest planet: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Try to see this particular belt. This is the belt which is in between Jupiter and Mars, and this is called as asteroid belt. Asteroid belt. Okay. This is asteroid belt that contains numerous lakhs of irregularly shaped solid celestial body. Solid celestial body. And these solid celestial body are called as asteroid. ये बचे कैसे? In the process of formation of planet, these were the planetesimals left over. And they were confined by the gravity of the Jupiter as well as Mars in this belt and revolving around the sun. So this belt, actually this belt is revolving around the sun, which is called as asteroid belt. So try to see this asteroid belt. Okay. Let's take up one by one planets. In this particular picture, you can see there is Mercury. Mercury. Okay. Mercury is the closest planet from the sun. It is the closest planet from the sun. Mercury is the closest planet from the sun. Okay. And it has a day temperature of the range 427 degrees centigrade. And the night is quite colder. Night temperature minus 173 degrees centigrade. If you compare the day and night temperature, there is a change of 600 degrees centigrade. So this is what the planet where the day and night temperature difference is going to be highest. Highest day-night temperature. This is what we call Mercury. It is the smallest planet. Smallest planet. ये क्रोमोस्फेयर समझाया, इसको इसमें ऐड मत करने. Smallest planet. It is closest planet. It is devoid of atmosphere. And due to no atmosphere, it has this much temperature variation. अगर एटमॉस्फेयर होता तो जो लॉन्ग वेव रेडिएशंस थे उसको रोक पाता, लेकिन यहां नहीं है. फर्दर द rotation of Mercury complete one complete rotation in 59 days. 59 days. While it complete one revolution in 88 days. तो 88 दिन में एक पूरा चक्कर सूरज का लगा लेता है और अपने अक्ष पे ये 59 दिनों में घूम जाता है. ठीक है. So day and night temperature. So it is the closest planet from the sun, but second hottest planet. Second hottest. So these are the fact find. We must be clear about that. Acha, we can see Mercury at both the time, evening as well as morning. Evening and early in the morning. This Mercury is visible, not always, but some point of year. When it is near the Earth, while revolving around the sun, it is visible from the Earth at every morning and evening. That's why we call it evening and morning star to Mercury also. So we call it evening and morning star. Evening and morning star. But the true evening and morning star is Venus. क्यों बच्चे? क्योंकि ये 88 दिन में चक्कर लगाता है, तो एक साल के अंदर 3 बार तो दिखाई पड़ जाता है ये, और मॉर्निंग और इवनिंग स्टार के रूप में. लेकिन मोस्ट ऑफ द टाइम Venus is visible. The second planet which we are going to see is Venus. Here it is Venus. And Venus is also called as twin planet of Earth. Twin of the Earth. And another name is sister planet of the Earth. Sister planet of the Earth. Fine. Why it is called as twin planet? Two reasons has been given. One is comparable size. Comparable size. लेकिन याद रखिएगा, Earth is bigger. Earth is bigger. तो साइज तो कंपेरेबल नहीं है. फिर भी जो दूसरी बात है वो ज्यादा सटीक बैठती है. इट इज द क्लोजेस्ट प्लैनेट. Closest planet from the Earth. So closest from the Earth, that's why it is considered a sister planet. Is it fine? हम ही लोग ने बनाए sister planet. अच्छा, Venus is the hottest planet. The hottest planet. Venus is the hottest planet. Fine. Venus is the hottest planet and the temperature is 475 degrees centigrade. Why it is the hottest planet? Because it contains dense carbon dioxide atmosphere. इसके एटमॉस्फेयर में ही कार्बन डाइऑक्साइड है. यहाँ 0.03% कार्बन डाइऑक्साइड है तो हालत हो जाती है खराब, ग्लोबल वार्मिंग. यहाँ पे डेंस कार्बन डाइऑक्साइड है बच्चे. That's why average temperature is what? 475 degree centigrade. It is the hottest planet. Further, Venus का जो रोटेशन है वो बड़ा ही मजेदार है. It rotates on its axis. Its axis in clockwise direction. बाकी सारे प्लेनेट यूरेनस और इसको छोड़ के एंटी क्लॉकवाइज डायरेक्शन में रोटेट करते हैं, बट इट रोटेट्स इन क्लॉकवाइज डायरेक्शन. एंड नॉट ओनली Venus, it is Venus plus Uranus also. Venus plus Uranus rotates in clockwise direction, while other planet rotates in anti-clockwise direction. It completes one rotation. It completes in 243 days, while one revolution it completes in 225 days. तो यहाँ पे जो ईयर होता है बच्चे, 1 year is smaller than days on Venus. 1 day is bigger than 1 year on Venus. यानी Venus पे जो एक साल होगा वहां के एक दिन से छोटा होगा. एक दिन बड़ा होता है वहां के एक साल से, क्योंकि एक दिन पूरा होता है 243 दिनों में और एक साल पूरा हो जाता है 225 दिनों. क्योंकि 225 दिन ये सूरज की चक्कर लगाता रहता है Venus, तो इसको ट्रू इवनिंग एंड मॉर्निंग स्टार कहते हैं. ट्रू इवनिंग एंड मॉर्निंग स्टार. True evening and morning star. Is it okay to everyone? Venus, and there is no moon with Venus. Venus के पास कोई moon है नहीं. Is it okay to everyone? These are the fact file. We all should have this understanding. Okay. इसके बाद अगला planet है बच्चे, red planet. That is what? Mars. कोई confusion हो तो पूछते चलिएगा. This is the next planet which we call a red planet. Why it is red in color? Try to see. It looks red because of abundance of iron oxide. That's why it looks red. Fine. Just like Earth, it is also tilted on its vertical axis by 25 degrees. So it is also tilted on its vertical axis by 25 degrees, and on this vertical axis revolve around, it rotate as well as revolve around the sun. So there is a tilt, and that's why due to this tilt, just like Earth, you will find seasonal variation over here. Seasonal variation. और इसी सीजनल वेरिएशन के कारण हम अगला जो अपनी बस्ती बसाना चाहते हैं वो कहाँ बसाना चाह रहे हैं? We are trying to have the settlement on Mars, क्योंकि Mars has similar seasonal variation, seasonal change, just like the Earth. Just like Earth. Not only this, Mars also rotate on its axis in 24 hours. तो वहां दिन और रात भी हमारे बराबर ही होंगे. Yes, it revolves around the sun and it takes longer duration. And revolution, it completes in 687 days. We have Mars has 2 moons, and that is what Deimos and Phobos. These are the 2 moons. And rotation, revolution we discussed, and it's called as a red planet. That is what? Mars. Is it okay?
Yes, sir.
Yes, sir.
Fine.
Yes, sir.
ठीक है बच्चे. मार्स के बाद अगला जो प्लेनेट है, नाउ वी आर इन द आउटर planet, outer terrestrial planet. So here we see the Jupiter. This is Jupiter. Jupiter is the largest planet. Largest planet. And not only this, it is made up of gases. That's why we call it gaseous giants. It is gaseous giant. And you will find that it completes one rotation. Completes one rotation in within 10 hours. Within 10 hours, it completes one rotation. And about one revolution, it takes 12 years. It takes 12 years to complete one revolution. And Jupiter is also known for a red color spot, which is referred as red giant spot, which is visible since 1664 till today. ये आज तक ऐसे ही बना हुआ है. Actually, it is a tropical cyclone. Tropical cyclone that had developed on the surface of Jupiter. Surface of Jupiter. So we call it red giant spot or the great red spot. Fine. You will find several such tropical cyclones developed on Jupiter. Try to see all these cyclones. Try to see all these cyclones. So many cyclones are developed on the surface of Jupiter because of its gaseous composition. Gaseous composition. But this red giant spot is what prominent, and since 1664, it is visible and we can see them. And there are many such spots are there. This is the biggest one, biggest cyclone of our solar system. That is red giant spot. So although Jupiter is a gaseous giant, try to see many such cyclones are there. It is a gaseous giant, but the core of Jupiter, Saturn, Uranus, and Neptune, all the core of these planets made up of heavy elements like iron and nickel. They have a solid core, and this core is solid. It's not like liquid or gas. It's a solid core. है ना? चारों तरफ गैस है, लेकिन कोर क्या है बच्चे? सॉलिड है. एंड सिर्फ जुपिटर का ही नहीं, सैटर्न, यूरेनस, नेपच्यून, इन सब का भी कोर सॉलिड है, ठीक है। एंड नॉट ओनली दिस, वन मोर थिंग which you should know about Jupiter, that it has largest number of moon. Right now, largest number of moon. In current scenario, it has largest number of moon. So there is a competition between Saturn and Jupiter in having the moon. There are many moon which is identified as moon, but yet to be confirmed. But right now, Jupiter is leading in number of moon. Sometimes Saturn is also ahead, but अभी मून के मामले में जुपिटर नंबर 1 हो गया है। तो सबसे बड़ा मून है उसका, वो है गैनीमीड। गैनीमीड इज द लार्जेस्ट मून, largest moon of our solar system. Ganymede is the largest moon of our solar system. Ganymede is the largest moon of our solar system. So this is the story of Jupiter. And one thing more, you can find annular ring, you can find gaseous ring around Saturn, but these gaseous rings are also present around Jupiter. The gaseous ring also present around all gaseous giants. All gaseous giants. But it is visible only in case of Saturn and Uranus. यहाँ visible नहीं है, they are not visible. These are not visible basically. These rings are not visible in case of Jupiter. जुपिटर में दिखाई नहीं पड़ते, और नेपच्यून में थोड़ा बहुत दिखते हैं, सैटर्न में दिखते हैं, और सॉरी यूरेनस में फिर नहीं दिखाई पड़ते आपको, लेकिन होते हैं. सो देयर इज गैसियस रिंग. हियर यू हैव सैटर्न. ट्राई टू सी सैटर्न. So Saturn is the second largest planet. It is the second largest planet of our solar system. Again, it is a gaseous giant, but density is the lowest density, and that is less than water. Less than water. Around this, there are 7 concentric gaseous rings visible. Once we talk about rotation, it rotates one complete rotation in 10.7 hours, and revolution, it revolves around the sun in 29.4 years. 29.4 years. Let me do one work. I'm just coming in 1 minute. Just wait for 1 minute more. Yes, we were discussing about Saturn, so revolution and rotation. And not only this, the largest moon of Saturn, that is what Titan, the largest moon of Saturn. And it is speculated that the Titan, which is what moon, frozen moon, and below the frozen surface of Titan, there will be liquid water. It is a speculation, so maybe possible liquid water is there. Okay, so for that, NASA is planning one mission, and that is what mission Butterfly you can see here. Mission. Okay. This is mission Butterfly. Mission Butterfly. Yes, sorry, not butterfly, it's dragonfly. असल में इतने सारे मैसेजेस आने लगे ना अचानक से यार thank you for this. So it is mission dragonfly. It's a dragonfly. Dragonfly, yes. It's mission Dragonfly, which is a mission of NASA destined to Titan in the year 2026. Okay, so it's a hovercraft. It's a like drone, and it will search the Titan and let us know whether it is right or wrong. वहाँ है कि नहीं. इसके बाद अगला है बच्चे यूरेनस. It's Uranus. Uranus. This is the third largest planet of our solar system. And again, it is tilted by 98 degrees from its vertical axis. That's why it is called a sleeping planet. Sleeping planet. So it revolves around the sun on its tilted axis. And that too in clockwise direction. Clockwise. So ये और विनस दोनों clockwise direction में revolve करते हैं. अगर देखा जाए rotation की बात की जाए, so the rotation is it rotates on its axis In how many hours? In 17 hours. 17 hours. And revolve around the sun in 84 years. Revolve around the sun in 84 years. This is the Uranus. Fine. Uranus also has gaseous rings, which are 13 in number. So there are 13 rings around it. Fine. And then we have Neptune. Here we have Neptune. Neptune. That is what ice giant. And it looks green. इसमें blue दिख रहा है बच्चे, but it looks green. Green color दिखता है क्योंकि इसके चारों तरफ मीथेन के cloud है, CH4 cloud. And they are the farthest planet. सबसे दूर का planet है बच्चे, farthest planet from the sun. Farthest planet from the sun. And it revolves around the sun in 165 years. 165 years. While it rotates on its axis in 16 hours. Fine. Neptune, revolution and rotation, its color is green, and green color because of this dense methane cloud. Fine. Then you can see this, in this figure you will find this Kuiper belt. Kuiper belt, that is also called as trans-Neptunian belt. Trans-Neptunian बेल्ट है ना बच्चे। तो ये रहा नेपच्यून, और नेपच्यून के बाद ये जो क्षेत्र है सूरज के चारों तरफ, दिस इज सन एंड दिस इज व्हाट कॉल्ड एज कुइपर बेल्ट। एंड ट्राई टू सी दिस प्लूटो। प्लूटो इज रिवॉल्विंग अराउंड द सन थ्रू दिस कुइपर बेल्ट। ये रहा प्लूटो, और प्लूटो इतना बदमाश है, हाईली इलिप्टिकल ऑर्बिट, नेपच्यून की ऑर्बिट को 4 बार काटता है। इंटरसेक्ट द ऑर्बिट ऑफ नेपच्यून 4 times. This is one of the reasons why it is not considered as planet. Fine. So this is Kuiper belt, and you will find lakhs of ice binaries over there. Ice binaries. Dumbbell shape ice binaries हैं ये सब, जिसमें प्लूटो क्या करता है, चक्कर लगाता है इसके चारों तरफ. So this is one of the reason why Pluto is no more planet. क्योंकि planet को क्या होना चाहिए, इसकी ऑर्बिट planet की क्राउड फ्री होनी चाहिए, फ्री फ्रॉम क्राउड. While the Pluto is not clearing its orbit. And second thing, it is intersecting the orbit of Neptune. तो नेपच्यून की ऑर्बिट को अगर इंटरसेक्ट करेगा तो फिर इसको प्लैनेट नहीं रहने दिया जाएगा. So it is intersecting the orbit of Neptune 4 times. That's why Pluto is no more planet. No more planet. इस पे एक इवेंट होराइजन मिशन है, उसके बारे में लिखा हुआ है बच्चे. And this is the picture of this ice binary. Ice binary जो कि आपको कुइपर बेल्ट में मिला था. So this is what a huge ice binary of 36 kilometer of diameter, you can say. It's a dumbbell shape ice binaries. कोई मैसेज आपका आया बच्चे? Yes, इसका नाम आरोकोथ था. This was Arokoth mission. This was Arokoth. This is the name given to this ice binary, Arokoth, in a Powhatan language. हवाई आइलैंड पे ये लैंग्वेज बोली जाती है बच्चे, हवाई आइलैंड. आरोकोथ का मतलब होता है इन हवाई लैंग्वेज something from very distant and celestial in origin. और इसका पता भी मिशन न्यू होराइजन नहीं लगाया था. न्यू होराइजन मिशन 2019 में जब ये कुइपर बेल्ट के पास गया था तो इसने ये फोटो भेजी थी. So this is the photograph, real photograph of ice binaries taken from closest what you can say encounter by any human endeavor. So this is what the special thing about this picture, R04, you should remember. Again, try to see selected moon. So we have moon, Earth has a moon, one moon. Chanda Mama Hamare, Phobos and Deimos, these are the two moon. In Mars, Jupiter has some moon, big moons are there, like biggest one is Ganymede, Callisto is also there, Europa is there, Io is also there, but this Ganymede is the largest moon of our solar system. And likewise in Saturn, the largest moon is Titan. Try to see this Titan is what? Largest moon. And when we compare the entire solar system, it is the second largest moon. Fine, Titan. Okay, and Uranus have also moon, but not so important. Titania is what a moon of Uranus. And let's come to the asteroid belt. Try to see this asteroid belt. Asteroid belt, which is between Mars and Jupiter. Lakhs of asteroids which were left over planetesimals revolve around the sun in this belt. And not only this, try to focus these belts also, these asteroids. These are the asteroids which are present in the orbit of Jupiter. So this is one line and you can see this orbit of Jupiter at 90 degree from the Jupiter. This distance is going to be 90 degree always and it revolves around the sun. And these asteroids are called as Trojan asteroid. Input Trojan asteroid. They are called as Trojan asteroid. So these Trojan asteroids are not going to breach their distance and they remain at equidistant, and this distance is going to be constant. Angular distance ये हमेशा constant रहता है. ठीक है. In some book you will find this is 60 degree and this is also 60 degree. But this one is called as East Trojan asteroid and here it is called as West Trojan asteroid. तो ईस्ट और वेस्ट में जो डिफरेंस होगा वो 180 डिग्री का होता है बच्चे. दैट्स व्हाई इट इज 90 डिग्री. सो कहीं कंफ्यूजन है, 60 डिग्री लिखा हुआ है बट इट इज 90 डिग्री बिकॉज ईस्ट ट्रोजन एस्टेरॉइड एंड वेस्ट ट्रोजन एस्टेरॉइड. हियर आल्सो यू कैन सी दिस asteroid belt over here. Try to see, this is Jupiter and this is one Trojan asteroid, here another Trojan asteroid. So this Trojan asteroid is eastern and here western. Okay, this is Jupiter and you will see that this is east and here it is west, and that's why it is East Trojan and West Trojan, and it remain in group and revolve around the sun in this entire system. This Jupiter along with East and West Trojan asteroid revolve around the sun. Is it fine? So this is what the solar system, and you know this solar system has asteroid. Let me give you some 4 largest asteroid, and out of this, Ceres is the largest asteroid, and Ceres is also called as dwarf planet. Dwarf planet. So it is the largest asteroid: Ceres, Vesta, Palla, and Hygiea. These are the 4 largest asteroids of our solar system. 939 kilometer is the diameter, 525 kilometer is the diameter of Vesta, and Pallas has a diameter of 512, and 434 kilometer is the diameter of Hygiea. These are the largest asteroids of our solar system. Fine. So this is all about asteroid. Let's come to this particular picture. In this particular picture, you can see a diamond ring structure. Basically, it's a diamond ring structure. And this diamond ring structure is formed at the time of total solar eclipse. Total solar eclipse. लेकिन ये जो पिक्चर है इसमें उससे भी महत्वपूर्ण एक चीज है बच्चे, वो है ये कॉमेट. Try to see this comet. So there is a comma shape comma shape celestial body that belongs to outer solar system. Outer solar system that revolves around the sun. Revolves around the sun. Around the sun on an elliptical orbit. So because of comma shape, it is called as comet. No, all these space mission is not important, but yes, once we discuss the space research in India, क्योंकि वो एक टॉपिक है, आपको मैंने सिलेबस पढ़ाया था, तो वहां पे जो स्पेस रिसर्च होंगे वो आपको बताए जाएंगे। तो केवल एक ही तो न्यू होराइजन मिशन, उसको भी तो मैंने कहाँ बताया आपको डिटेल में, वो तो आपने बता दिया आरओ पोत, और वो तो मैंने सोचा उसको डिटेल कर लेते हैं। आप समझ पा रहे हैं? बट यस, स्पेस रिसर्च ऑफ इंडिया इज इम्पोर्टेंट, स्पेस मिशन ऑफ इंडिया इज इम्पोर्टेंट। तो उसको जब हम लोग पढ़ेंगे, वो टॉपिक चल रहा होगा तो उसमें बातचीत होगी, है ना। यहाँ पे देखें बच्चे, आउटर सोलर सिस्टम से आया हुआ ऑब्जेक्ट है, जिसको आप कॉमा शेप देख पा रहे हैं, कॉमा है। इसमें आप देखोगे कि देयर इज अ फ्रोजन हेड। ट्राई टू सी दिस, आई एम जस्ट यूजिंग अनदर कलर। दिस इज द हेड ऑफ द कॉमेट. This is head of the comet, and it is frozen gases. And then you will find extended tail of this comet, and this extended tail actually illuminated by the solar light. And once you watch it from the sun, earth, it seems as if someone is just showing us torch from the sky. So this is a comet, and this comet has a tail. Try to see, this is a nucleus. This nucleus is a frozen comma. This is a frozen head. Let me write here. It's a frozen. Frozen head, which is made up of gases, frozen gases, plus solid material also. Solid material, it may be heavy elements. Heavy elements. And not only this, you will find a tail, extended tail, which is made up of gases. So many gases are there. There may be carbon dioxide, carbon monoxide, there may be methane, there will be HCN, okay, there will be hydrogen. So all these gases are there, and it is extended away from the sun. This gaseous tail is extended away from the sun, and do remember it is what? Straight. Straight. While there is another tail which is made up of dust. Dust tail. So we have two tail, one is made up of gases, another one is made up of dust, and you will find this dust tail is little bit curved. Curved क्यों होगा बच्चे? क्योंकि इसमें dust है, heavy elements होंगे बच्चे, heavy metals, तो थोड़ा भारी होगा. So it's not as straight as the gases are, but it is little bit curved, and it is always directed away from the sun. So try to see, this is the comet which is moving towards the sun, and when it is moving towards the sun, the tail is always directed away from the sun. Tail is always directed away from the sun. And once you are on the earth's surface, suppose that this is the earth and you are watching this, so इस पे solar light टकराती है और तब आप तक पहुंचती है, and it get illuminated, और आपको ये extended tail काफी दूर तक आसमान में दिखाई पड़ती है. So it's my personal observation. I have seen comet, and it was the Hale-Bopp comet. Hale-Bopp comet, and it was visible on 23rd July 1995, and almost for 3-4 years ये इनर सोलर सिस्टम में था और हमें दिखाई पड़ता था. बचपन था उस समय, तो रोज देखते थे हम लोग, तो ऐसे लगता था कोई टॉर्च जला रहा है, ऐसे टॉर्च कोई जला रहा है, फोकस आसमान से और दूर तक ये लाइट यूं आ रही है. सो इट इज विजिबल लाइक दिस. तो अर्थ पर इसी तरह से दिखाई पड़ता था. तो दिस टॉर्च इज एक्चुअली द हेड, एंड दिस एक्सटेंडेड टेल इज देयर. सो इट इज विजिबल एंड ब्यूटीफुल सेलेस्टियल इवेंट. सो आप भी देखोगे इसे. इसे तो नहीं देखोगे, लेकिन जो पहला कॉमेट था, दैट वाज हेली कॉमेट. हेली कॉमेट, इट वाज द फर्स्ट कॉमेट व्हिच वाज actually discovered, Halley comet. It was seen by Edmund Halley first time in 1986. Okay, Halley comet, this is the first comet, and यही से डिस्कवरी भी हुई कॉमेट की, पता चला ये कहाँ से आते हैं, और इसका जो टाइम पीरियड है बच्चे वो 76 ईयर्स है, फिर दोबारा ये 2062 में दिखाई पड़ेगा. सो द टाइम पीरियड इज ऑफ 76 ईयर्स. तो याद रखिएगा, this is the time period for Halley comet. And if you see the Hale-Bopp comet, so Hale-Bopp comet has time period which is quite longer, 2533 years. So ये अगेन आएगा तो जरूर, लेकिन तब तक हम लोग कहाँ होंगे नहीं पता, इसके देखने के पूरे चांसेस. ठीक है. So this is what comet we have discussed. Next topic, which is quite close to this astronomy, is what? Meteoroid, meteor, and meteorite. Meteoroid, any celestial body which is approaching towards the earth, celestial body which is solid, obviously solid, and approaching towards the earth under the gravity of the earth, we call it meteoroid. Just 1 minute, I'm coming. So any celestial body which is solid moving towards earth under its gravity is called as meteoroid. It may be asteroid. So when it is approaching towards the earth under its own gravity, it has certain speed, and normally it is more than 72 kilometers per second. This is the speed of approach, and if this is the speed, it enters in an atmosphere, especially the mesosphere. In mesosphere of atmosphere, where it burn into ashes, and when it burn into ashes, we call it shooting star, or here we call it meteor. Okay, but sometimes they are not totally burned into ashes, and they are able to strike the earth, where we call it meteorite. And this meteorite has massive impact, and due to this impact, a lot of debris thrown into the space, into the atmosphere, and this debris are going to block the sun rays, and due to blocking of the sun rays, earth is undergoing global cooling. And this global cooling is responsible for mass extinction. And there was a global cooling happened at the time of Jurassic period, and there was a mass extinction of dinosaur that have taken place. है ना बच्चे? So this is what meteorite, meteoroid, and meteor. This is the basic difference. In these figure, we happen to have solar eclipse and lunar eclipse. इसको मैं तब बताऊंगा जब अर्थ के रोटेशन और रिवोल्यूशन को बता दूं. तो आज इतना ही. एस्ट्रोनॉमी के जो इंपॉर्टेंट टॉपिक्स थे वो आपके सामने मैंने बता दिए. ये नोट्स मैं शेयर कर दूंगा, और इससे आप एक बार पढ़ लीजिएगा, और जो भी कोई आप किताब पढ़ रहे हो उसको इससे ऐड कर लीजिएगा, इट विल सर्टेनली हेल्प यू। ठीक है, दो छोटी छोटी चीजें रह गई हैं जिसको मैं बता देना चाहता हूँ। एक तो गोल्डीलॉक्स जोन, और एस्ट्रोनॉट बेल्ट तो हो ही गया था, गोल्डीलॉक्स जोन यहाँ पढ़ लेते हैं। पहले देख लेते हैं व्हाट वेयर इज द गोल्डीलॉक्स जोन। तो गोल्डीलॉक्स जोन एक तारे के रिस्पेक्ट में वो डिस्टेंस है जहां पे कोई प्लेनेट अगर हो तो वो प्लेनेट ना तो तारे से बहुत पास है ना तो बहुत दूर है, वो एकदम उस जगह पे है जहां की वाटर कैन रिमेन इन लिक्विड स्टेट। सो दिस इज व्हाट गोल्डीलॉक्स जोन। So it is neither so close from the star and nor so far from the star. It is at a sweet spot where the water can remain in liquid state. यहाँ पानी तीनों अवस्था में मिल सकता है। Water can remain in liquid state. Liquid state water is the most important form which is required for origin of life. Origin of life के लिए सबसे important कौन सा पानी है बच्चे? लिक्विड स्टेट में। अगर बहुत ज्यादा टेम्परेचर रहेगा तो वो वाटर वेपर फेज में होगा, और बहुत कम टेम्परेचर होगा तो फ्रोजन फेज में। लेकिन पृथ्वी इतने अच्छे जगह पे है, ना तो वो सूरज से इतनी दूर है कि पानी जम जाए, और ना तो इतनी पास है कि पानी वेपर फेज में हो। एग्जैक्टली उस फेज में है जिसमें ओरिजिन ऑफ लाइफ हो सकती है। यही कारण है कि अर्थ पे लाइफ है ना बच्चे? दैट्स व्हाई दिस गोल्डीलॉक्स जोन इज आल्सो कॉल्ड एज हैबिटेबल जोन। हैबिटेबल जोन, ठीक है। हैबिटेबल जोन वो एरिया है जहां जीवन संभव है, और जीवन संभव होने के लिए पानी का लिक्विड स्टेट में होना जरूरी है। दिस इज ऑल अबाउट योर एस्ट्रोनॉमी। टेक केयर ऑफ दीज नोट्स, रीड इट, एंड इफ यू फील एनी कंफ्यूजन यू कैन सेंड योर क्वेरी इन फॉर्म ऑफ मैसेजेस, एंड वी विल टेक क्लास टुमारो। तो कल एक क्लास होगी ट्यूसडे को, हो सकता है वेंसडे को मैं क्लास न लूं, तो अल्टरनेट क्लासेस अभी चलेंगी, लेकिन कल हम लोग क्लास ले रहे हैं। वेंसडे को हो सकता है हम लोग क्लास ना करें, तो टुमारो विल बी द क्लास। So thank you very much. I'm just saving this notes and this will help you to understand the process. Okay. Is there any query from your side? So you can ask. कोई सवाल है बच्चे आपके मन में? So shall I sign off?
Yes, sir. Thank you.
So
Yes.
take
Thank you,
good care.
sir.
Thank you very much. Tomorrow we are meeting. Thank you.